So yeah,
it's not that big of a thing, really.
Not that big of yeah, of course.
Yeah,
not.
I'm just shy. I'll just be here.
Okay. So yes, I want to keep this very relaxed, very open. The goal is to inform our audience and our followers as much as possible. The two guests that I invited, they both crypto enthusiasts. So we just want to get their candid response of how they felt after reading the Litepaper. And then after that, we'll just let them ask any questions they have. The two guests have decided to be anonymous, and that's actually for a very good reason, because they are very big privacy and security concerns around blockchain and crypto. So I wanted to ask Coin if you could quickly mention a couple of things we want to say to our audience about staying safe.
Okay, yeah, sure. Just as a general guideline, keep your keys to yourself. From the Coinweb team, you got to check that the URL that you're using is correct and that the account is official. There are a lot of fake accounts and scam accounts, so make sure that you're with the correct channels. Also, we will never ask you for your private keys or ask you to send us money or anything like that. As a matter of fact, a lot of people who are admins we won't DM you first, so we will likely not message you first. If there's a question that you need to ask us, we might tell you in the group to send us a direct message, but be wary of anyone who contacts you claiming to be part of some other team or group or anything. So yeah, just some few guidelines. And
thank you very much. So first up, maybe our two guests, or you can say anything you like about yourself. Also, if you want, you can explain why you've chosen to stay anonymous. It's up to you. And once you've introduced yourself, I'll introduce Knut and Alex.
I can start. I'm in the space since early 2017, interested in the whole development around distributed ledger technology. In the last cycle, very focused on what's going on in the space of interoperable chains and smart contracts, focused on Cosmos and Polkadot. That's also why the specific interest in Coinweb, because my theory is that we'll see a patchwork of interoperable blockchains that will change the world in terms of data processing. So yeah, interested to hear how Coinweb works and how it achieves full interoperability, basically.
And I've also been in crypto since 2017. I share Ursus's belief that we're going to see a mushrooming of ecosystems that will need interoperability, and I think that is what makes Coinweb interesting. And I'm interested to hear how you're going to pull this off.
Thank you very much. We have. Let's see if Alex will manage to stay in the call. But maybe before that, I just want to introduce Knut, who is the CTO of Coinweb and in many ways the mastermind behind a lot of this. So please introduce yourself.
Yes, so I'm Knut Arnevinger. I've been working with Coinweb since 2017. My background is hardware and software development. And I got into electronic currencies quite early in 1996. So I've been following this field for quite a while, on and off. So been working with that. I've been working with telecom and other sectors. But for periods, I haven't really worked a lot with it, but I've always been following the field as it's been developing. So in the beginning, these electronic currencies, they were very centralized. And for that reason, some of them failed. And I think maybe Bitcoin was created as a result of that. So I saw Bitcoin being created very early. So I just saw some discussion groups and so on. It was just a few weeks since the launch. I looked at it. It was very interesting, but I didn't really get involved. I followed the development and so on, but I didn't really get involved before a couple, 2-3 years later. I got started to use it. I used this as a user and not an investor, unfortunately. So, but yeah, that's how I got into cryptocurrencies and Coinweb.
Thank you very much, Knut. And now let's see if we have Alexander. Are you here?
Yeah, I'm here.
Okay, thank you very much. Can you just maybe have a brief 1-minute introduction of yourself?
Okay, I'm Alexander. I'm not sure why my camera is not working, but yeah, something is. My background is in computer science. I worked for Google for many years. I worked a little bit in the beginning of my career. I worked on the Linux kernel. did some cryptography implementation there. I've been interested in cryptography and privacy for a while. I did a startup in privacy and another startup in security, and also have a little bit of machine learning as background. But I'm more or less a generalist. While I worked at Google, I also worked on video conferencing. So I did work on the backend for this system, Google Meet. I've been in Coinweb since 17 or 18. 17. And in Coinweb, I am overseeing development and looking at the architecture and things like that. I'm a pretty hands-on person. I try to be everywhere and try to see what's happening in the different parts of development and company. So that's a little bit of me.
Thank you very much, Alex. So yeah, I would like to hear from both of you guys. How did you like the Litepaper? What did you like? What didn't you like? I think we can talk about this for another 10 minutes or so, and then you can have any questions to our guys.
Sure. I think the Litepaper is, I like the Litepaper. I like the, it gave a very easy to read overview. The introduction was a bit too general for me. I would have hoped to get more of a on point on Coinweb. I think this is also something I look forward to on this call, because I still can't quickly summarize what it is, and that's something I look forward to. I think that would make the project easier to understand. The rest of the Litepaper is great. I really like the animation. It helps. The visual context helps a lot. Yeah, that's kind of my 2 cents there.
Yeah, same here. I think it reads pretty well. I think it looks super beautiful. I love the animations and it looks really slick. Yeah, I still struggle a little bit to understand exactly how this technology works. I think it does a good job at outlining the problems, and it talks about some solutions, but I think I still have some questions. But I think it gives a very good introduction. But I think we'll probably have some questions we want to have clarified. They're not mentioned here.
Okay, great. Alex, Knut, do you guys have any questions you want to ask before we go into their questions, or should we go directly in there?
We can go directly.
Yep.
Okay, great. So, Rune, since you have your name on the video, should I call you Rune, or what should I call you?
Yeah, sure. I have a feeling that there's several Norwegians here, so yeah, we're
okay.
I give away my nationality here, but.
Okay, so Rune, do you want to just fire off your first question that you have?
Yeah, in terms of the cross-chain, I mean, exactly how does this work? How do you facilitate this actual cross-chain? You talk a lot about the delay and everything, but do you have liquidity pools, or how do you burn? I guess you don't burn it. Do you hold this token and then release it on another chain?
Yeah, I can go a little bit into that. Maybe we can start on the theoretical side and then go to the practicals. So there was this interesting paper that was referred to by Vitalik and others that proved that cross-chain communication is impossible without trusted third party or synchronous communication. And the secret that Coinweb, the thing that we are doing is that we are creating a layer on top of the individual blockchains, so the layer 2, and it's the layer 2 that is cross-chain. So we communicate between layer 2s. Layer 2 we call shards, and the shards are one-to-one with layer 1 blockchain. So there's one shard for Ethereum and one shard for Bitcoin, etc. And the trick in Coinweb is that, let's say that the shard that lives above Ethereum does not only take its data from Ethereum, it also takes data from, say, L1 or Bitcoin. So there are certain transactions that appear on L1 and Bitcoin that will also appear in this layer 2 shard. Let's say a jump transaction is entered into L1 and it should appear on Ethereum. Then that will happen in both chains atomically. So that transaction will be on Elrond and it will be on the Ethereum shard. It will happen atomically, but it will not happen at the same time. So it will appear in Elrond, and then after some time it will appear in Ethereum. But it cannot appear in one and not in the other. And that is the way that we solve this problem. So basically we have synchronous communication, because by definition a certain transactions can appear in two shards. So what we have is that we have a layer 2 that is cross-chain, that reads data from lots of different chains. So this is sort of a building block, the Coinweb core. Now, given that we have that, we add reactive smart contracts. What they give you is the ability to also atomically change layer 2 state based on something in layer 1. So you enter some transaction in layer 1 in Ethereum, let's say transfer 1 ETH from one account to another. Now that's seen at layer 2 and it can atomically also change state in layer 2. So let's say there's a contract in layer 2 that listens in and it sees that this transfer is happening. Okay, then I will move some L2 tokens. Okay, so given those two things, we do one change in layer 1, it will affect layer 2, and layer 2 can also then affect layer 2 on top of another blockchain. Okay, so all of that is completely deterministic and there is no consensus needed to drive this. So the last part is to get from layer 2, let's say on layer 2 on Bitcoin, down to layer 1. And that is the place where we will also use reactive smart contracts. So let's say somebody is doing a move of Bitcoin and it will affect layer 2, for example, release collateral or something like that. But that last part needs to happen through some economic incentive mechanism. Like, for example, if somebody doesn't do it, some L2 tokens will be burnt or something like that. But what we have done is we have broken up the cross-chain problem into sort of constituent parts, which is reactive smart contracts, so that you can react in layer 2 based on something in layer 1, and the ability to communicate deterministically between layer 2 shards. And that leaves only one last item, which is how to affect layer 1 in the target blockchain. Some external party needs to take action on layer 1. In my view, it makes creating bridges and things like that much easier and also much more powerful, because you can have bridges and things like that that have complete oversight and complete knowledge of what's happening at layer 1. Not just what you have, for example, in native bridges, where you submit some proof of something that happened on another chain, but that whole mechanism is very bandwidth limited. There's a lot of things that you simply can't do, like, for example, tracking every transfer that happens on layer 1. Did that explain a little bit how cross-chain works?
Yeah, I think it would be very useful to map these things out because, I'm reading this, I'm like, okay, is it a layer 1, is it a layer 2? And, I think a little map of that would be, so it seems to be that you guys are both layer 1 and layer 2.
Maybe since you're mentioning the map, maybe I'll just share my screen so we can look at the 3D model while we are explaining these things. And then I'll actually mention what you want to show.
Yeah, okay, so we call ourselves layer 2, but the input data to layer 2 is coming from layer 1. So that is similar to how rollups work. Mm-hmm. So if you do a rollup, you put the data inside of layer 1, and then layer 2 is sort of an rollup interpreter for data. So layer 1 just ignores the data, but layer 2 interprets that data as a program.
These layer 1s are not Coinwebs. These are blockchains like Bitcoin, Ethereum, L1, and so on.
Yes, so very distinct between Coinweb and, for example, Polkadot or even Cosmos is that we are a layer 2 that can basically run on top of any blockchain. In this example, you have Bitcoin and Ethereum, which are completely distinct. They don't share any consensus. They don't share any common implementation. Everything is different between those two. If you look at, for example, the Cosmos ecosystem, then you can also have many different blockchains, but they all share the same consensus mechanism. They all run Tendermint so that they can more easily communicate. Or then if you look at Polkadot, all the different chains actually share the same consensus. It's just one consensus. It's just that it's a two-level hierarchy. So the real consensus is in the relay chain in Polkadot, and then the chains have their own consensus. And that is why it's possible to communicate easily inside of Polkadot. We're trying to solve the more general problem, and by connecting what we call self-sovereign chains that don't really care about anything outside their own chain.
And then you have your own network of nodes powering that, right? And I haven't found a great deal of detail. Is that a proof of stake network?
No. Coinweb is a little bit similar to rollups in that rollups typically they don't run, say, proof of stake or any consensus mechanism because the data that is entered into layer 1, as an example, let's say that there's some data in layer 1 where it says 1 + 1 + 3. And then layer 2 is supposed to compute that. So that answer is 5, and it's given that it must be 5, and there is no choice about it. So you could add a consensus and a network of nodes that run consensus between each other and says, okay, if more than half of the nodes say that their answer is 5, then it's 5. That is one way to do it. But there's a better way to do it, and that is that you can take any computer program that is deterministic. So given that you know the input, you can look at it as, for example, a spreadsheet. If you consider any computation as basically a big spreadsheet with lots of formulas and stuff like that, it's possible to divide the computation of that spreadsheet into individual updates of one cell. I'm starting from A1 and I'm updating that, and then A2. And so I have a sequence of operations. And what we are doing is we're using a different proof mechanism where we look at computing that spreadsheet as a sequence of operations. And if there is any disagreement, so let's say you have a network of 100 nodes and I'm a client and I ask 30 of those nodes, what is the answer? And then if one node says something else, or if there are 2 or 3 answers among those nodes, instead of looking at the consensus algorithm, what I do is I start a protocol called RDoC, referee delegation of computation. And what that does is it takes that sequence of operations to compute that spreadsheet, and I divide it into half. So I ask the node, so what is the answer to this left-hand half of the spreadsheet? What does that look like? And then they say, okay, it looks like this and that, and maybe they're all in agreement. Then I know that the disagreement is somewhere on the right-hand side of the spreadsheet. And I ask them, okay, what's the upper half of the right hand? And then at some point, I find basically one instruction, one update to the spreadsheet where there's disagreement between the nodes. And I can narrow that down to a single instruction. And then the client will execute that themselves. And this technique has been used in TrueBit. It's been used in optimistic rollups and a few other projects. It only works for deterministic computations, and therefore it doesn't work for a layer 1 blockchain, because a layer 1 blockchain solves a different problem. What it solves is, let's say I have a spreadsheet and I have 1,000 people wanting to edit that spreadsheet, and it's sort of arbitrary who gets to edit the spreadsheet. It represents the transactions that are going into the next block. So let's say you have 50 other competitors, and then there needs to be agreement on who are the next 10 edits to this spreadsheet in the next. That requires consensus. There's an arbitrary decision. Just a decision needs to be made, but it's arbitrary. In this case, it's deterministic. So we have the inputs and there is an answer, and there's only one correct answer. And the problem we're trying to solve is, how can I make sure that the answer is correct? And RDoC gives us the ability to find any cheating nodes. So we have a node network. We do have a node network, but it doesn't run any consensus algorithm. And this is the reason also why we don't foresee a huge network of nodes. Like, for example, in Ethereum, you have 400,000 in the validator set for the beacon chain, for example. We'll probably see a fraction of that. On the other hand, that gives us the same kind of security, because you only need one honest node reachable from the client. And it also gives another opportunity, and that is to increase the computational load that can be given from the users of Coinweb. So we can do much more complex computations because we don't need to run the computations in hundreds of thousands of nodes.
Very cool. Actually, we run some nodes. So do you allow anyone to operate a Coinweb node, and do they have to put up CWeb as collateral, or how's that process?
Yeah, so anyone can run a CWeb node, And in order to run a CWeb node, you basically need to run a cluster of computers. And on that cluster, you run Kubernetes, which is this cluster management system. So you need to run on multiple computers, but we're going to provide everything that you need to run that. But it's a little bit, it requires some big computational resources to do it. The nodes, they don't need to put up a lot of collateral, but it's not finalized what they need to put up. What we're trying to accomplish is that we want the clients, when they hook up to the network, the light clients, your mobile phone, and there are some 100 nodes, what we want is to avoid Sybil attacks. So somebody sets up 50,000 IP addresses with invalid data. So we want some sort of collateral, but the collateral is just to make it a little bit harder to do Sybil attacks. So when you connect to a number of nodes, there should be extremely low probability, even during a Sybil attack, that you don't connect to an honest node. And that requires a certain amount of collateral and even a certain amount of burn, because collateral in itself has this nothing at stake problem where you can provide false information that you actually have staked. So a combination of staking and burning, yes, but it will not be extremely expensive the way that you see in proof of stake systems.
Right.
Where we typically need to put up millions and millions of dollars.
And how do the nodes get paid? Is it paid through like inflationary means, or do they get a percentage of the transactions, or how do you? There's not much on tokenomics here, so I think that's interesting.
Yeah, so the nodes, there is a fee for the transactions. So the fee that you pay for entering your transactions into the network is partially to pay the L1 embedding, and then to pay for the L2 computation. And then for the L2 nodes, they will get compensation for the running of the nodes. But we are experimenting a little bit on how to exactly do the distribution of those rewards. We don't only want to incentivize the nodes, we also want to incentivize users. We're looking at various models a little bit similar to credit card fees, where you can have cash back and other things like that. So it's sort of a shared model who gets part of those fees.
Okay.
And another thing on the tokenomics and incentives for the nodes is that we put aside quite significant chunk of tokens for the mining supply. And since the network is deterministic in nature, it means that we don't necessarily need to pay a huge chunk of tokens for keeping consensus and keeping sort of nodes honest, because the proof mechanism is very powerful in making it very hard to cheat in the system, since you only require one honest node. And that makes it possible for us to use quite a lot of tokens for various subsidies, either making it more profitable to run a node or subsidizing in layer 1. Was it 1.8 billion tokens set aside for mining supply, Knut?
Yeah, it's 1.76.
And mine, so does that mean that these nodes are mining, or what does that mean?
Yeah, no, they're not. It's called the mining supply in the tokenomics.
For stakers?
Yeah, the main usage initially for this was to incentivize L1 miners. So they would receive CWeb when they included a Coinweb transaction. So this would be a way for Coinweb transactions to be prioritized. But there's related use cases for this. Basically, all of them are incentives for the network.
Yeah. Other areas where we're considering using the mining supply is for staking around the connections in the network. So when you have two chains connected to each other, there is a parameter that says how much time should pass before information from one shard, how long should it take before that information should be available in another shard. And that parameter it's basically there just to not have too many reorganizations at layer 2 in the target shard, just because we don't want reorganizations to ripple through the network. So we want changes that happen to be sort of stable. And you can stabilize that by having a little bit of delay for the information. But exactly what the delay should be and whether the L1 is stable or not, and whether the consensus works and things like that, that we don't have situations like the block just being stopped and shut down and restarted and manually going in and editing the blockchain and stuff like it. It's sort of, we have all sorts of things now. Not all blockchains are like Bitcoin and Ethereum. And staking to say that I believe that this blockchain is stable and it will not be stopped. I'm betting on the fact that the block interval on this blockchain is never going to exceed 3 sigmas on the distribution of block intervals, for example. If it happens, then I'll lose my stake. Things like that, which becomes information in the market that we can use to automatically set these parameters. These are also areas where we're looking to use subsidies to get those markets off the ground.
Cool.
I have a question. How do you make the L1 chain data available at all time to the Coinweb L2? And the other way around, how do you basically transfer the data from the Coinweb 2 to the L1s? Like how does it work?
For L1s, to get the data from L1 to L2, Coinweb is running L1 clients or blockchains. So for example, to read L1 data on Ethereum, we have the Ethereum transactions that are formatted in a special manner and include a lot of call data, which is this data section that you can add to Ethereum transactions. And this is the same way that rollups, say zero-knowledge rollups or optimistic rollups also work. You send a transaction into L1 that includes a data field that is just, from L1's point of view, it's just some opaque data that was added to this transaction, and L2 will basically scan all the transactions coming into L1 for things that are relevant to the L2. There are a little bit different ways of doing that. So you can have a contract, for example, in L1, and then you only scan transactions going into that contract. There might be a specific function that you call that does nothing. For example, in Ethereum, you might create a contract. It has a function that does nothing, but when calling that function, you add a lot of call data, and that is embedded into the chain and then parsed out from layer 2.
There's like a prefix, something that the layer 2 will recognize for layer 2 specific information. It's just a mark on this transaction, and then Coinweb understands, okay, this is some information that I have to look at and act upon. And then in addition to that, you can also monitor native events on L1.
I think it would be really good to have an animation, showing the layer 1, layer 2, and how these kind of packets and contracts kind of interact.
I have a question for you. Do you have a concept of how rollups work? Because one thing that I often use rollups as a reference point, but I don't know if that makes sense for people or if it just confuses because you're not aware of the technique that rollups are using for this embedding of data on layer 1.
Not 100%. I'm still trying to wrap my head around how these sequences work for optimistic rollups, for example. And I think that would definitely be interesting to see, like, how does that work for Coinweb?
I think a lot of people know, CK rollup and the concept of it, but I think the actually understanding how things get communicated, I think very few people understand. So.
Could we maybe at this point quickly roll up these 3D models we have both of our map and of the node and then see if that helps? Yeah, so basically in this 3D model, you see how Coinweb works. You have the underlying chains here, Ethereum, Bitcoin, so on. And here's the Coinweb layer. These represent individual nodes, and on top you see dApps that interact with all of this. One of your questions was, how does this interact from down here, up here, and then back down? What you can see in here is transactions in the block. You see white ones, and you see a blue one here, and you see an orange one here. These blue ones, they represent a Coinweb transaction. This is what Knut mentioned, that there was a transaction inserted into Ethereum that has some kind of code. Now, on top of this, every process node basically has these scanners, and these are reactive smart contracts. They are observing these blocks, and whenever they see a transaction with this code, they say, oh, I need to basically copy that into here and then process that. However, Knut also mentioned we constantly monitor all of these. So even if you just say, I don't need to look for a Coinweb transaction, I can just look for, let's say, if guy A ever sends money out, that transaction is interesting to me, I'll look at it. I'll just monitor that account. So these reactive smart contracts are one of the things that allow us to take information from layer 1 into layer 2. And the breakthrough here being regular smart contracts cannot do that because they cannot just run indefinitely. They keep needing to be paid by an external source. So these reactive smart contracts, they can just keep running because they can have their own wallet. So they can just keep 100% monitoring any chains around them. So I think this is how the information flows from layer 1 into layer 2. Then here, of course, we have this processing, and that's what Alex mentioned with the RDoC, the delegated proof concept, and where we might have hundreds of nodes that then process any kind of data, and that comes up into this fusion data. That's kind of the one-way stream. Fusion data is just data that's taken from Ethereum, Bitcoin, other chains, and fused together and processed to improve upon. Now, we don't have a direct way of changing layer 1. However, we have the Coinweb token that is up here that pays for processing and various different things. And we incentivize, up here you see a third actor. These are information traders. They scan on this fusion data screen. We can advertise that we pay CWEP for anybody who might write information into Ethereum or into Bitcoin or into another chain. So we say we have this price. If you write this data into the underlying chain, you get this CWEP price. And of course, there is a third kind of mechanism because we can transfer data from one chain to another in our kind of simulated or mirrored chain up here on layer 2, but we cannot directly write it down into layer 1 for security reasons. So that's why we say if there's a need to write into the actual layer 1, we basically give a price, say which data has to be transferred, and then this third party can do it, which makes this process in the end decentralized both ways. That's my take on it. So,
yes, I think that is an important point because the goal of Coinweb is not necessarily to move L1 tokens. You can do that as well, and it's a good use case. But what it really is a general computation layer on top of many chains. It's a very, very powerful layer on its own, much more so than most L1.
Can I just quickly add this explanation? First of all, was this illustration here helpful in how this moves? And was my explanation helpful in understanding how this kind of two-way communication works?
Yeah, helps.
Yeah, I'm still trying to understand how many entities are involved to get the data back on the layer 1 chain. Like Knut, you said, I think you were about to explain that.
Yes, so the moving from L2 to L1, that is something that is for the application layer. So Coinweb provides a way to make sure that whichever mechanism you use for that will work. If you're a provider of that service, you would commit to write to L1 to move, for example, Bitcoin in there. And to be able to do that, you would have a collateral. So if you do not do that, you get a penalty. And whenever you do it, you make a profit.
But just to put this a little bit in context to other systems, every system that is doing something like this is based on some sort of incentive. And if you want to make an incentive system decentralized, it's always based on some sort of collateral that participants put up, staking, and rewards. What is different about Coinweb is that it makes it easy to make those incentive systems because you can put up a contract that monitors waiting for this exact thing to happen on L1, and when it happens, you will give some reward at L2. And then you are able to do that on different chains. You're able to set up a contract that monitors something on Elrond or Solana or Bitcoin, and you can have that contract connect to another contract, and thereby you can create swaps and bridges and these other things that you see so many projects are doing, but they're doing it integrated into sort of one project and using typically some external chain or consensus or programming this native bridges. What we are providing is this layer that enables all that kind of cross-chain functionality. But I wanted to comment on just one thing that I feel is important when it comes to Rollup and also Coinweb. The reason why this two-layer thing even exists is because layer 2 can avoid consensus, and consensus is extremely expensive. So what we're saying is that there is one part of this problem that is non-deterministic, and that is deciding what work that should be done, what transactions should exist, and what is the sequence of operations in the Bitcoin chain or the Ethereum chain. That is a non-deterministic problem. It requires consensus. Consensus is expensive. You need lots of nodes and you need lots of capital. But the way to reduce that cost is to make the computations required to run that network as easy as possible. And Bitcoin is actually one of the best at this, because the Bitcoin network doesn't allow even smart contracts. The computations that you do for processing a Bitcoin block is very, very simple. You can do it on your mobile phone, which means that you can have a huge network of Bitcoin nodes participating in validating Bitcoin blocks, and the network is incredibly secure. When you increase the computational load that is required for everyone that validates blocks, and then Ethereum is an example of that, then the hardware requirements grows, and then the number of nodes that can participate shrinks. And then on the other extreme side, you have, it says EOS. EOS has just some nodes, and it's not decentralized at all. Now, the solution is to stick with what Bitcoin did. Don't put too much logic into layer 1, because it's just going to destroy the decentralized nature of layer 1. And then you can do incredibly complex computations that are deterministic. You can have a layer 1 program that is the input to computing nuclear explosion or a neural network or something like that. You just give the parameters, and then the incredibly big computation is deterministic. That is what you put into layer 2, and then you only need a fraction of the number of nodes. And that is the core of why we're doing this. We're creating a computational network that can scale, because if we can't scale, we can't create all these things that we want to do on the blockchain. So that is why we have to have this two-layer approach. It's the only way that we know of to make this work for the future, to be both decentralized and scale.
No, I think a graphics showing that would be very helpful.
Yeah, I have one question still. How would a cross-chain transaction work? Are there liquidity pools in the bridge kind of sense, or how would it work, like an ETH transaction onto the Bitcoin blockchain, for example? Is that possible, and how would that be facilitated?
Yeah, it does require some sort of liquidity pool, or at least some sort of collateral pool. So it could work a little bit like Thorchain. Let's assume that there is some sort of mechanism to figure out the price. First, I figure out how many ETH am I supposed to get. Okay, we can look at various ways of doing that. Could be just automated market maker, liquidity pools, or it could be some other thing. But let's say there's some way to figure out that. But the mechanisms in Coinweb that will be used for that is that first you move your Bitcoin to some address. And on the other side of that address, there is somebody that has layer 2 collateral. So you ask layer 2 Coinweb, where should I move my Bitcoin? And layer 2 will say, okay, if you move your Bitcoin to this address, this project that is built on Coinweb will ensure that you get your ETH. And let's say there are various actors that are active in this sort of pool of collateral. You pick one of those addresses. You send your Bitcoin to that address, and then atomically that would trigger a requirement to, say, release a certain amount of Ethereum on the Ethereum blockchain within a certain period of time. Or else you would receive the equivalent in CWeb tokens plus some penalty, for example. So the deal is that I move my Bitcoin to this address, and I get one of two outputs. Either I get a certain amount of ETH on the Ethereum chain, or I get a certain amount of CWeb.
That means you would have a liquidity provider that is either one-sided, and then there's two of those with Bitcoin and ETH, and both of them would have to post collateral in CWeb to facilitate a transaction in the same value they posted collateral as CWeb.
Yeah, so that would be similar to how Thorchain does it when you have collateral in Rune, for example.
Yep.
The difference is that this is deterministic, so there is no consensus on Thorchain involved for this. So when you move your Bitcoin, there is no need to provide any proof and get it into a third chain. So let's say on Thorchain you move your Bitcoin, then somebody will provide the proof and put it into the external chain. Now that is a non-deterministic process that you sort of introduced there, because this third party might not do it, but there is a consensus. The consensus is basically which proofs are we going to allow into the Thorchain for the next block. And since you have miners, since you have consensus, it means that you also have things like censoring. You can take control over a consensus system. You can attack it. When you have control over it, means you can censor information. You can reorder when the information enters the chain, etc. These are problems that don't exist in Coinweb because it's deterministic. So whenever your Bitcoin is moved, it triggers something in L2, a reactive smart contract that somehow reacts to that and will send some message to the Ethereum chain. And there is no way to censor that. There's no way to reorder or make that not happen, because it happens by definition. It is the protocol. There is no consensus involved to do that. The downside, because there's always trade-offs in this, the downside is that if you look at the Thorchain, they can connect any chain into this one communication channel, which is Thorchain, and then they can use that as a sort of broadcast medium. On the other hand, Coinweb, we have a fixed, more or less fixed. It's dynamic, but it changes very slowly. Communication pattern. So let's say you wanted to do the swap between Bitcoin and some arbitrary chain that nobody cares about, and it's not connected directly to Bitcoin. So you have to go from Bitcoin to Ethereum to Elrond and then to the, cousin of Elrond chain and then to some sibling, and then you go to this unknown chain that nobody cares about. So now you have to go multiple hops, while on Thorchain you would go directly. That is the trade-off. But I think that that's a much better trade-off, because the attacks that you see on these small sort of bridge-like chains, they are real. They are getting attacked, and that the consensus system is or will be attacked. So removing that attack vector is much more valuable, I think, than having to go a few extra hops. And then the network, Coinweb network, will be organized by traffic and stability, so that if you have very high, like if the customers or the users of the system really want to exchange a lot of value between Ethereum and Bitcoin, they will obviously be neighbors in that network so that they communicate directly. So in practice, it will only be like insignificant swaps between who knows what that will take longer for settlement. And then even you have the information market on top that will make this immediate. But yeah, that is an example. In between, instead of this, you can have AMM, for example, to set the price for that swap. But the main mechanism is to have collateral. Collateral is sort of the driver for getting things done.
Okay, yeah.
So the idea is these actors that expedite transactions across chains, that provide liquidity on the different chains, they are guaranteed settlement in the Coinweb layer because it's deterministic. So you remove one layer of insecurity, and that makes the market more effective, because it's just, and so it could probably be cheaper and faster.
And also we talked about earlier the incentives for the consensus that you need, for example, on Thorchain. The need for those kind of incentives is much lower. So you can spend that, the inflation that you have on consensus-based system, you can spend that on something else. Maybe to make it cheaper for the user, for example.
And you wouldn't need that consensus because you'd have the data on the L1 chain that is monitored by the Coinweb system. Is that correct?
Yeah. So the Coinweb shard is defined more or less like this. We make a block which contains all the Coinweb data that is embedded inside of the L1 block, plus jump transactions that exist on the neighborhood blocks. That is a definition of a block that does not include any arbitrary decisions that need to be made. The next block is going to be the next L1 block plus jump transactions. It's well defined. Anyone can compute it without having any information except the contents of L1 and access to neighborhood shards. Okay, if we compare that to, for example, Thorchain, what is the definition of the next block? Well, it's like you have, I'm not an expert in this, but I'm just explaining how it would typically work when you have consensus. You have a mempool, you have competing transactions. Those transactions could be like proofs of that I moved a Bitcoin on this chain, or it's some sort of data. But they're all in competition to get into the next block. And then there are miners and proof of stake and some consensus mechanism that decides whether those transactions are getting in or not. Now that is non-deterministic in the sense that it's not defined by the contents of Bitcoin or Ethereum or any other system. Now the input is defined as a mempool. The mempool is non-deterministic. It can be arbitrary information in the mempool. And you can inject arbitrary stuff without going through the L1s. So the Thorchain would be, because it's non-deterministic, it requires consensus. It's an arbitrary decision. We compare it again to optimistic rollups. Optimistic rollups is, we have the sequencer. Sequencer has the same problem that there needs to be some sort of decision on what's sort of the next block. So that they introduce non-determinism there, which is quite unfortunate. But if you look at the on-chain data, you can compute the state of the optimism layer by just reading the data that goes into their contract. You read the data that goes into the contract, then you compute layer 2. The only thing you need access to is basically an Ethereum node. You need to read the data out of their contract and you need to do all the computations, but then the answer is sort of given. So also they don't have any extra consensus. Does that make sense? Maybe?
Yeah. Could you use oracles like Chainlink to read the on-chain data on the L1? Or would that defeat the purpose and introduce like a security risk?
Yes. So oracles are also consensus driven. Well, it depends. Oracle is sort of a wide concept, but definitely one of the original uses of an oracle was to introduce completely non-deterministic data like what is the weather and bring that on chain, or what is the current stock value, what is the current price of Apple on the New York Stock Exchange, how to get that on chain. And that requires a consensus. Typically it requires either an authority, like some public figure saying, okay, this is the Bloomberg contract, and as Bloomberg I will just post what is correct information, and if I post not correct information then you can shame me. That's not decentralized. You're trying to make it decentralized, and then you introduce some sort of consensus, like, and then there's some nice things about Oracle systems, like you can introduce penalties for being more than a few cents from the average. You can do some nice variations of consensus, but it's not deterministic. So what we don't use an Oracle network. We basically just run the nodes, or if you don't want to run the underlying blockchain nodes, so you only need to run the nodes for the Coinweb shards that you want to run. But we assume that you have an API where you can read data from the L1 blockchains that is secure. What that means is that you run a node or you use the services of somebody that you trust. So if you run a node, that means that you have some software in your system that runs the consensus algorithm, and therefore you can trust the data. If you outsource it to some third party, you basically have to trust that they run the correct consensus algorithm and give you correct data. But yeah, I don't think using an Oracle network gives us anything because, as you said, it introduces an extra layer of consensus that just reduces the security.
Understood.
Very cool.
Great. I think that's all. I have exhausted my questions. And,
thank you very much.
Thank you so much for all your time.
I think we have a much better view of the project now, and you know, we got a lot of things cleared up. So that's really cool.
Yeah, I also want to ask, what do you think generally about this kind of Q&A?
Yeah, I think it's great just having all of you on for almost 2 hours and being able to ask anything. And it's fantastic. It's great to understand more. And I think if you do a series like that and make that information available, I think that this is fantastic, especially for newer projects and in specific for Coinweb, because I mean, you're trying to solve the most complex problem at the moment in the blockchain space, and that's real cross-chain communication. So I think an event like this definitely helps clear up a lot of questions, and I'm pretty sure if you repeat that with other communities, there will be new questions, and it gets much clearer how to make the information accessible in an easy fashion, I think.
Actually, we keep saying this is our Litepaper 1.0. This is where we try to take all the wealth of information that you've seen now here, how much there is to this project. We wanted to take that and condense it to something that's understandable in a reasonable amount of time. And now the next several months, we want to test it with you guys, with many other people, and then continuously improving our messaging. Right? That
sounds like a great approach.
Thank you. I do think there's definitely going to be value in putting the entire call online. I don't think it's something that's going to, go viral, but I think a lot of the followers that we have will watch this and get a lot of information. So we're going to edit it and everything. I'm definitely going to, ask you guys before we would post anything so you can check it and we make sure that everyone's in agreement. But yeah, I'm very happy about the results of this.
All right. Thank you so much.
Thank you very much.
Thanks, everybody.
Bye, guys.
Bye-bye.
Okay, bye-bye.
Bye-bye.